everyone, this is Good Night. Today we are going to present the acidulants in food systems. In this production part, I will introduce the general function of food acidulants and how to choose the right acidulants. Can you imagine a chewing gum soft drink with only sweet taste? It is like a Coke without gas and sun without sunshine, so it will be flat. Now you must know what is the function of the first acidulants? Yes, adding flavor. The acidulants will add sourness and enhance flavor. Then the next function is adjust the pH. The acid provides the right pH to help the gel formation and cheese making. Moreover, by lower the pH, the acid can also act as a preservative. More interestingly, the acidulants also responsible to adjust the appropriate pH to maintain the biocidal action in some preservatives. For example, sorbate, the active form to kill the microorganism, is between pH 3 and 5. Some acid can also act as a buffer to avoid a rapid change in pH and maintain a constant acidity within the food products. Acidulant is also one part of leavening agent. The reaction of salt bicarbonate and acid can form CO2, which give the major texture and appearance in baked foods. In addition, acid can also protect the loss of nutrition value, and they can also use as nutrition additives by forming a salt or esters with some essential nutrients. From previous presentation, we know that acidulants are really a powerful food additives in food processing, but how we select them? First, we need to know what is the state of the acids. The first step can narrow down the choice. For example, if products cannot handle liquid acids, the liquid form acid can all be excluded. For flavor, different acids have different taste. For example, citric acid provides sharp taste, while lactic acid is relatively mild. Choose them depend what flavor you want. Then the ability of moisture absorbing and the solubility also need to be considered. If acid is hygroscopic, such as citric acid, then we may consider to use non-hygroscopic acidulants or consider a water-impermeable package. For solubility, glucose, beta-lactose, and fumaric acids has low solubilities, which limited them in some applications like beverage powder production. However, low solubility become advantage in control leveling in bakery applications. The last factor, again, is pH. You need to know what the pH range of your products. Usually 1% acids lie in the range of pH 2 to 3, but some research still needs to be carried out to decide the added concentration of acid due to the different properties of acidulants and the complexity of food matrix. This is the first part of our group. I hope you have a general overview of food acidulants. Now, my teammate will introduce more detailed information in some commonly used food acids and their application on food industry.
Hello everyone, in my part, I'm mainly talk about ascorbic acid and phosphate in food system. The structure of ascorbic acid is shown in the figure. Ascorbic acid has acidic nature and function as color preservative. It also has antimicrobial properties with nitrate in meat product. Additionally, it plays a role as antioxidants and it can supply nutrients. For example, ascorbic acid can preserve color on shrimp, asparagus, and peaches, and to preserve color and flavor in juice and wine. As an antioxidant, the concentration of ascorbic acid cannot exceed 150 ppm in canned applesauce. Ascorbic acid and its sodium, calcium, and ferrous salts are used as nutrient supplement, such as vitamin C. Besides, bacillus cereus can be prevented in raw sausage as a combination of sodium isoascorbate and sodium nitrate. Phosphate has multiple of functions in food products. It's consisted by a central phosphorus atom, which is surrounded by 4 oxygen atoms. And phosphate has multiple forms, which is shown in figure. Actually, different types of phosphates have different pKa's, varies in different pH. The function of phosphates in different types of products plays different roles, and specific phosphate is used in different types of products. In bakery products, phosphate play roles of leavening, door conditioning, pH adjustment, pH buffering, starch modification, and so on. In cereal products, the addition of phosphates can expedite cooking, such as 0.5 to 1% DSP is used in macaroni formulation. Phosphate can form better gels to resist low temperature and have clearly viscous. It functions as leavening agents, buffering, and chelating agents. In meat products, phosphate can stabilize color, increase tenderness, retard oxidation, and so on. For example, polyphosphates with sodium chloride can stabilize the lipid and color during storage of beef and pork to prevent oxidation. In dairy products, the primary use of phosphates is the cheese pasteurized process, which functions as emulsifier to form stable emulsion and give melt or flow properties to cheese. TSPP helps to the suspension of cocoa in chocolate milk and helps the rehydration in dried and concentrated milk. During vegetable and fruit processing, the functions of phosphate are chelating metal ions and acidification, such as the use of SAPP on potato surface. In beverage products, such as cola and root beer, phosphoric acid plays a role of acidification. Iron and calcium phosphate can supply minerals. About 0.05% and 1% of phosphoric acid belongs to add in cola and root beer. Phosphate salt can react with sodium bicarbonate to form acidic salts and release carbon dioxide, which functions as leavening agents. For example, MCP is used in bakery food to increase carbon dioxide releasing rate.
Hello everyone, I'm going to talk about two common acidulants in food system, acetic acid and citric acid. First, let's meet acetic acid. I believe that we are all familiar with one flavoring in our kitchen, vinegar. And this kind of acid was discovered from vinegar, which also gives its distinctive sour taste and a pungent smile. This may help you understand why it is being used so widely in food industry. Acetic acid can be produced both synthetically or biologically. The fermentation only accounts for about 10% of world production, but it remains important for the production of vinegar because many food purity laws require vinegar used in foods to be of biological origin. There are some major examples of the production of acetic acid. It can be used in confectionery goods and flavorings. These main applications of vinegar include products such as pickles, sauces, and ketchup. It also has excellent bactericidal properties and hence has considerable importance as a preservative. When used according to good manufacturing processes, acetic acid is generally recognized as safe for foods. Then, let's say hi to another common acidulant, citric acid. Citric acid is a natural weak organic acid that is found in many fruits and vegetables, especially citrus. Because citric acid is also a byproduct of the citric acid cycle, it is also produced by many living organisms, including mold. Citric acid is prized for its sour flavor, preservative quality, and ability to act as a pH buffer. Here's how citric acid can be used in food systems, and the main applications among them are citric acid can provide sharp taste in soft drinks and sweets. It can prevent browning of sours, and it can act as an antioxidant in fats and oils. From these pictures, we can see citric acid is really useful in food industry. We all know that citric acid is considered to be a harmless additive by food regulating agencies all over the world. However, public concern has arisen from its erosive effect on teeth, and there are a small percentage of the population is allergic to citric acid.
Hi everyone, now I will talk about another two food acidulants, glucanol delta-lactone and soybean acid. Glucanol delta-lactone is one of the important additives in food products. In New Zealand, GDL can be used as an acidity regulator or raising agent. GDL is not an acid, but it will hydrolyze to gluconic acid when it dissolves into the water. There are four main functions of GDL. Let's get some applications. In meat products, by adding GDL can enhance the pigment formation and keep a constant low pH, which can reduce the use of nitrite. From the graph, we can see the sausage with added GDL convert more pigment. In United States, the maximum use of GDL in meat is 5,000 ppm. In pasta and rice, GDL can provide the acid environment to keep the gluten from denaturation. This preserves the smooth texture of the noodles. It also can prevent the dough to form black spots by microorganisms during the storage. By reducing pH, GDL can also chelate the metals, which is able to prevent the fruit and vegetables from enzymatic browning. The most common use of GDL is in the manufacturing of cheese and tofu because it can reduce the pH slowly, which is mimic the fermentation procedure. In salad and sauces, vinegar can reduce pH but cause undesirable flavor, while GDL can provide a low pH but keep the flavor. Soybean acid is another general food additive used as a preservative. The normal use level is from 500 to 2500 ppm. The pKa of soybean acid is 4.8, so it can inhibit most of the mold and yeast in low pH. In cheese products, like cottage cheese or some fresh cheeses, treat with soybean acid can prevent mold from attacking cheese's surface. In pickled vegetable, 0.1 to 0.2 of soybean acid can suppress the growth of yeast and mold, but do not affect the formation of the dissolved lactic acid. In bakery products, soybean acid can prevent the mold but also the yeast, which is a problem. However, this problem can be solved by using coarse particle soybean acid, which can release the acid slowly and don't inhibit the yeast. That's all. Thanks for your attention.